Okay, on the reading. So the big deal today is talking about what a function is, okay? A function is where every x value is paired to exactly one y value. So the problem here, the example I showed you, is if I had bought one latte, it cannot have two prices. This would not be a function, right? So the x value cannot have two y values, right? So a relation can, though. A relation is just pairing one value to another. That's a relation. But the difference between a relation and a function is the fact that the function can only have one value paired to it, okay? Domain. Domain's all possible x values. So the x values are also going to be what the horizontal is. And the range is all possible y values. We're going to learn about this more in our notes, okay? Now the vertical line test is an easy way to tell whether or not something is or is not a function. If you can draw, listen, if you can draw a vertical line anywhere on your graph, and if it hits your graph in more than one place, it is not a function. If you can draw a vertical line anywhere on your graph, and if it hits the graph in more than one place, it is not a function. Okay, so let's take a look at the notes. So today, we are talking about functions. That's our topic. It is a Common Core FIF, interpreting functions. So right off the bat, we have the definition of a function. Okay, let's make sure we have this, because I think on the next quiz, this will be your first question. Hint, hint, hint. Very first question in your quiz is, what's the definition of a function? There it is. Every x value is paired to exactly one unique y value. That is the definition of a function, okay? So what's the big deal? Well, let's take a look at it. If it's not a function, it doesn't make sense. So example 1. So I'm driving up to the latte stand, and it's buy one for $3 and get one free. So that means I could buy one latte. I get the second one free, and the price would be $3. So to graph that, I could have a dot there, and I could have a dot there. Okay, so I buy one latte for $3 and get the second one free. That can happen. That happens all the time. I like those deals. This is a function. Every x value has exactly one y value. Each x value has exactly one y value. That is a function, yes. The vertical line, if I were to draw it, test would pass. It's only going to hit it once. It's going to hit it once. So yes, this is a function. Yes. It also makes sense. That can happen. But now, example 2, we drive up to the latte stand, order one latte, and the teller tells you it's $3 and $4. So the teller, she doesn't know what she's talking about. You buy one latte, and it can't cost $3 and $4. It's either going to be $3 or your latte is going to be $4, right? So it's a function. You can only have each x value is paired to only one y value. This one's paired to two different y values. This is not a function. Each x value, that's one here, can't have two y values. So this is not a function, okay? Now that whole thing about a vertical line test is if you can draw a vertical line down, and if it hit the graph in more than one place, it's not a function. Sure enough, check it out. If I draw a vertical line straight on down, boom, boom, it hits it twice. If you ever draw a line and it hits it more than once, it's not a function. Okay, example 3. Now, every x value has to be paired to every unique y value. So I get the point 3, 2, 4, 1, 5, 3, 3, 1. Okay, now there's a problem with the 3's. And we'll also graph it. There's a problem with the 3's. This 3 is paired to 2, but the 3 is paired to 1. Which one is it? Is it supposed to be paired to 3 or is it supposed to be paired to 1? It can't be both. Now, an easy way to do this, if you don't see that, is just to graph it. If you do a real easy little sketch of the graph, you got 1, 2, 3, 4, 5. And so we'd have 1 point at 3, 2, 4, 1, 5, 3, but then 3, 1. You have a problem right there. X, the x value of 3, is paired to two different y values. See that? This x value 3 is paired to two different x values. It's not a function. No, it's not a function. Now example 4 is just looking at the graph, okay? Now even though this is a parabola, you watching? This x value only has one y value. This x value only has one y value. This x value only has one y value. This x value only has one y value, and so forth and so on. Every x value has a unique y. This is yes. Now that vertical line test says, can you draw anywhere and hit the graph in more than one place? No. This is a function. Yes, yes, yes. Each x value has one unique y value. But if you look at the other one, it's not. This x value right here, it's got two different y values. It's got one here and one here. That's not a function. So if you have an x value, any x value that has two different or more values, it's not a function. But check this vertical line test out. Fails, doesn't it? Fails it here, fails it everywhere. So if you can draw a line anywhere on the graph, if it hits the graph in more than one place, it's not a function. Yeah, Will?
Why does it matter whether or not it's a function?
Great question. So we live in a computer society, right? We have machines that are doing all sorts of things for us, right? Even your car. So the way a programmer codes things is through commands, right? So you have an input, and the machine gets your input, and it gives you a corresponding output. So with computers and computer languages, we want to make sure that things are a function. And the example I gave earlier is that, for instance, we're in an automotive plant. We program the car. We say, okay, here's what we want to do. The machine, we want you to, say, fix a wheel, right? Which wheel? There's 4 different choices. Which is it going to try and fix all 4 at once? Maybe we only want to fix the right wheel. Well, no, there's 2 right wheels. Which one? So does that make sense? So as we learn, so we're moving into higher math, and the people that actually use this stuff do it in a lot higher sense. Does that make sense? Right? 1 input, 1 output. Fix the left front tire, okay? Be very specific, okay? All right, now, how about the last example? It's kind of tricky, isn't it? It's just right here you have a problem. Right here, this x value really has 2 different y values, doesn't it? So this is not a function, okay? Okay, not too hard. Okay, ready to turn the page? All right. Okay, example 5. Chart shows pairing of coordinates which needs to change. Okay, so to make it a function, is it a function? It is, because every 3 goes to 1, 5 to 0, 7 to 9. Everything's unique, so yes, it is a function, okay? Now, the domain. Let's go back to the domain. The domain are all possible x values. So if I look at the domain on this one, I'm going to say domain is equal to 3, 5, 7, 9. That's just the x values, right? Just all possible x values. These are my x values. That's my domain. My range is going to be my, and I'm going to put it in order. I'm going to go 0, 1, 9, 23. All possible y values is my range. And that's it. Domain is all possible x values. Range is all possible y values. Okay? Thumbs up. That's it. That's it. Done.